tone for my presentation. It talks about the progress made by semiconductor industry. And the number of milestones which are noted here had a great relevance for me because those years are very important years of my life as well. So it was around the year I was born that Texas Instruments invented the first silicon transistor. By the time I went to school, Mr. Robert Noyce made his first silicon semiconductor IC. By the time I went to the college, it was the first microprocessor 4004 was designed and marketed by Intel. And by the time I got my first job, it was Intel 8086 which came into the market, and that drove the whole revolution of Intel IBM compatible PCs. And look at today. They are talking about, and let me tell you that first microprocessor had only 2000 transistors. First PC chip which went to a PC had only 50,000 transistors, and today they are talking about 1 billion transistors chip to be released next year. Now, if semiconductor had made such great strides, and I was only thinking about if same progress had been made by software, it would have been somewhere totally different. So that is the topic of my presentation today, the new paradigm for software solution development. But before I do that, let me take you back to how the software was built. Of course, I can't go back 50 years because there is no probably software written in the formal way that we are talking about. But let me go back to when I did my first job. Software was written on a printed stationery called 80-column sheets. You would write on your program, take it to somebody who was a person sitting in an AC, very unbearable job, who was punch card operator, who would create a deck of cards, will submit it to a computer and hope to get a printout maybe next day. Actually, it's not a joke. The actual story that when we were doing the first project, actually we would create a big deck of 2000 cards. You won't need to go to the gym. Only when you lift the card deck, you will do all the exercise. So you go to the data center, submit the job, and I was, actually my parents lived in Pune. We'd go on a weekend to Pune and hope to get a result when we come back from Pune actually. So that was the state. Of course, things have changed significantly. All the earlier software tools or languages like COBOL and Fortran got replaced eventually by Pascal and C, or even later by C++ or Java. But I think things did not change significantly. The software development paradigm was almost same, and let me illustrate a little bit. The software engineers were still, all of you know that software engineering is a very young industry compared to other disciplines like maybe civil engineering or mechanical engineering. And the focus was jumping to the construction and not doing design. And engineers were all actually doing the job equivalent to the bricklayers of the civil engineering. And the topic of my presentation is to change this paradigm. And of course, I'm not going to talk about upliftment of the societies who are economically backward, but I consider a generation of software engineers actually as the blue collar and not white collar. And the tool or process we are going to talk about actually trying to convert to a white collar software jobs. To convert the science, convert the whole programming experience into a science rather than an art, focuses on design and models. And we use models in our every day-to-day life, really speaking. And in doing all this, improve the productivity while maintaining still the quality. Let's look at an example of the analogy I was taking about civil engineering. When somebody wants to build a 2-story, 4-bedroom house, he or she will probably tell you about they want rooms of so-and-so size, they want so-and-so amenities, the room should be facing east and not south and all that. And then probably other things like parking slots and this and that. But the house owner does not expect civil engineer to come and start digging the ground the next day. They'll come back with the blueprint and probably will come out with the layout, 1 or 2 or 3 even to take your opinion as to what you like, whether what is going to be built is what you want it or not. And maybe then there will be other plans like the electricity plans and the plumbing plans and whatnot, air conditioning and all that. The focus is on visual representation. The civil engineer, architect tells you how your house is going to look like, how is going to be the elevation look like. When you see from the distance, how will it look like? When you are inside, how the drawing hall will look like. But that was not what was happening in the software. Maybe at the best, software people who are going to use software will tell you the requirement, but probably they will not know until it was built how it's going to look like. And that's what we are trying to create. We are going to look at the whole software as a series of business processes getting converted to workflow models, into design models, and then to application, which hopefully at the end of the whole process will actually do what it was intended to do. So in the whole building of software, we are trying to have a focus on visual representation of the software. We are going to use some standards which are becoming industry standard, and in the process we are going to use tools and techniques while constructing the systems. In the whole life cycle management of this, there are multiple challenges. As the systems become complicated and very mission critical, of course they become larger and larger. And so also teams which we are going to build becoming larger and more unmanageable. Of course, for example, somebody is building a house, two-story house, probably engineer or architect can still think about it, even if he doesn't document, he can still make sure that it is realized. But think about this campus being built. The architect cannot convey his ideas to the next person in the value chain unless it is documented well. So that is the whole challenge, and then there is limited automation in that, and there is a heterogeneous tools. So we are trying to overcome this. So what we are trying to do is the whole software already we built is for some end use. For example, you are using for automobile engineering. So what you do is there are processes you encapsulate using an ERP or a CRM, and you try to implement that and probably reduce the cost of building that software and build the product to the market. We looked at our own process. We are an IT company. What is our business process? Can we look at our business process? What is the ERP that will help us to automate our business process? And that's what we try to do. And that's the tool set we are trying to build. So let me give you a 30,000 view of the whole toolkit we have built. We have named it a solution blueprint because we are very much attracted by the blueprint concept, which is a very great visualization tool, and that helps us everybody to communicate with each other. So what we are doing is at the basis of this is a model-driven architecture, and you use UML and BPMN as the standard languages to define the requirement. And we have built a number of accelerators to convert from business process diagram to use case diagram to class diagrams and eventually to test case. So at one end, BPT is a representation of the user requirement. In between there are design artifacts, and when you test it is again a business scenario. So the whole process is a series of tools which convert from one model to other model, and that's how you automate the process. So who are the players who get benefited in the process? The business analyst, the architect, the designer, and the developer at the end of it. So this is a peep into the whole complex environment or a framework we have built. I'm not going to go into the details and talk about, but it suffices to say at the moment that at one end we have a business requirement and we have to finally bring out the solution. There are various stages in between. There are multiple tools here. Some of the tools are industry standard tools. Some of the tools we have built ourselves. But the more important thing is the glue that is built, which makes sure that all the tools interact with each other. So in this process, we create what we call blueprints, and this becomes a repository. These blueprints are whatever we have done in the past. Also, there are some standard blueprints which have been created, which are vertical specific. So if you are, for example, working for a utility company, or for example, a telecom company, there are a lot of processes which are common between the various different telecom companies. So there are some patterns emerging, and those are industry-specific tools. And there are some foundation libraries also. For example, any software you build, the way the results are rendered on the screen is same, the way the errors are captured is same, the way authentication of the user is done is the same. So there are some foundation libraries also. So the repository is something which forces the reuse, and that makes sure that what we use, what we create is also available for the next generation as well. And at the end of it, we create a solution which is actually realization into the real world. So important thing in this is what I was talking about, converting the bricklayers into the designers, is try to deal with the whole process in the model itself and not into the directly diving into the solutions. Let me talk about how it is used. For example, the development process. Obviously, it has a requirement, design, and then the construction process. So we'll try to create engineers who actually should be engineering and not doing any other work. Is actually to spend more time in the first two phases, and the third phase should be actually by and large automated, and that's why we're trying to do as forward engineering and automatic generation of documents. Documentation is something which has made life of all software engineers very miserable, and we are trying to automate the documentation generation itself. Of course, one designs new applications. Maybe it takes 6 months, 9 months, 12 months, but it is used for next 6 or 9 or 12 years, and it has to be maintained and enhanced on an ongoing basis as and when business changes. So this tool that we have developed also is useful for support and maintenance also. What is shown here at the top is a conventional way of doing it. What we have is your artifacts of your program, and every time there is a change in the business, whether it is because of you are rectifying an error or you are adding a new feature, you change the source code, you have to change the document. Every time you do that, everything changes, and you have to again, next time you want to do it, you have to learn about the whole thing. If you are using this tool set, you are using only at the model, and every time you use the model, the subsequent thing can be automated. Of course, this model, the whole process also has a one disadvantage, that if for whatever reason, because of time pressure or skill pressure, you choose to alter the code, the model becomes irrelevant. And that's exactly what we are trying to do, what is called reverse engineering, or which will make sure that any time there is source code change, you change the model automatically itself, what is called round trip engineering. So through round trip engineering, we have made sure that whether you make change in the code or in the model, it can be synced at any time. And that's why it always model remains very relevant. Otherwise, the incentive of using model goes once you tamper with the code directly. This is of actually putting this to use. This is what we call a global delivery model. And what we have done is, for one of the, let me tell you from the example, real life example, we are working for a European company, and we wanted to use the teams wherever they are from various different geographies. So we had one set of expertise which was available only in UK. Then we had sort of designers who were available only in India. We had testers who were available only in Poland, and we still had to make the whole process work. And this was possible only through the global delivery model, which was a real-time collaboration, which is the most important thing, which has been also incorporated in the whole design and toolkit. What we thought that what we have done so far must be shared with the society also, and try to, we had created a version which we have put into the open source, and this is now available for anybody for use. We are using again Eclipse as a platform, which is the most popular platform, and it's in open source. We are using standards like UML and 2.0 and all other things which are again standards. So through this we are trying to propagate and trying to create a generation of software engineers who are actually doing engineering work and not the bricklayers. So what it does is basically the benefit of model is you model once and you can deploy it anytime. Same blueprint analogy what we talked about the house. If you have to build 1,000 houses of same type, you can do it the same way using the same model. That was not the case earlier, the way software was defined or developed. But only by using this technique we can do that. We of course reduce time to the market and automate the thing. What we have also done is, now that we are talking about this affecting the way people work and improving their quality of work or day-to-day work, we are trying to backward integrate into the academia also. So we are given the exposure of all the toolkit which are given to the students in the engineering college, even in the second and third year. So by the time they come out of the college, they are already ready for use in the industry, and they are well versed with the new technique of design a house. And of course, this can be used for various different life cycles of the application, whether it is product development, product enhancement, product documentation, or legacy migration and application development. All that can be done through the same toolkit. So let me end up by saying that with a story. There was a wise man who was going around the countryside in India, and he saw an activity of 20, 30 people who were doing something with the stones. So as he came closer, it became evident that they were only cutting stones. So he approached one person and asked him, what you are doing? So he said that, you fool, can't you know that I'm cutting stones here? I'm cutting stones. He said, okay. He moved to the next guy. Then he asked him, what are you doing? Of course, he was also doing cutting stones. He said, I'm constructing a building. Then he approached the third person and he says, what are you doing? He said, I'm building a temple. All three guys were doing same thing. They're doing the same job. They're doing same stone cutting, but each of them understood the purpose differently. The third guy knew he was building a temple, and what he was doing at that moment was only means to an end. So in the same way, if the software people are not doing just cutting codes, but know what is being done, how it is going to be used, and if model and visual aids are helping him doing that, that's what the difference we want to bring into the so many blue collar software jobs and make them white collar. Thank you.